Welcome back to Learn with Roblox. In today's video, we're going to talk about permutations and combinations, which both talk about the number of ways that I can arrange objects, but there's a difference between them. Let's talk about permutations first. The formula for a permutation is if you do n p for permute, r, this is equal to n factorial over n minus r factorial. Now, what are n and r? N is the number of objects you have. And then r is just the number of positions you have. As an example, let's say you're putting 6 books on a bookshelf and there's only space for 4 books. You'd have 6 objects, your 6 books, and 4 positions that you can put them in because there are only 4 spaces to put the books. So that's what n and r would be in that example. And then let's review what a factorial is really quickly. The way a factorial works is if you have n factorial like that, this is equal to n times n minus 1 times n minus 2, and you do that so on and so forth until you multiply by 1. So as an example, if you have 5 factorial, that's equal to 5 times 5 minus 1 is 4, the next number is 3, and then you do that all the way until you get 1. And that's 120 if you compute it. So that's an example of a factorial, and we're going to get very familiar at using these. Let's talk about a combination next. So the formula for a combination, if you do n CR for combination or choose, that's equal to n factorial divided by, you still have n minus r factorial, but now you have to multiply by r factorial again. So this is the formula for a combination. Now these are clearly different formulas. One in the world I'm going to use permutations, and one will I use the combination formula. The trick is this. For permutations, the order matters. So lay that down. Order matters. And for combinations, you use them if the order does not matter. So I'll write that down. Order does not matter. And we'll go over some examples to show you what order means and explain when order matters and when order does not matter. But let's get into some problems that involve permutations and combinations. Our first problem at the top says, in Roblox's The Hunt event, there were 10 finalists. In how many ways could first and second place be determined? To do that, we need to consider, does order matter or not? Well, let's see what the problem says. The positions we have are first and second place. Well, here, I think order does matter because getting a first is way different than getting a second place. So this means, do we use a permutation or a combination? Well, we know that order matters. That means we use a permutation for this problem. So let's think about how to set up the permutation and solve for the answer. So remember, a permutation you do, or let me just do, n permute r, and let's think about what n and r are supposed to be. Well, for n is the number of objects you have. Here we have 10 finalists, so that's our n value. And then r is how many you're choosing out of those. And here we're choosing first place and second place. Those are 2 different positions. So that means we have 10 permute 2. And then remember, the formula is you have n factorial divided by n minus r factorial. So let's replace n and r with 10 and 2. So n factorial becomes 10 factorial, and then n minus r is just 10 minus 2 factorial. And then 10 minus 2 is just 8. So our denominator is actually just 8 factorial. Now let's talk about how to compute this. I'm just going to redraw this down here. If you have 10 factorial, that's equal to 10 times 9 times 8 times 7, and you do that all the way until you get times 2 and then times 1 divided by 8 factorial is 8 times 7 times 6. Do that all the way until you get times 2 times 1. I want you to notice something. Notice how everything in here is up here as well. In other words, I want you to notice that if you have 8 factorial down here, we also have an 8 factorial up here as well, because 10 factorial is equal to 10 times 9 times 8 times 7 times 6, so on and so forth, is just 8 factorial. So this is a neat trick you can use to cancel out factorials easily. So I'm just going to cancel these out now, and that leaves me 1 in the denominator. So I'll have over 1, 10 times 9. And then 10 times 9 is just 90, and 90 divided by 1 is just 90. So we just have 90 ways that we can arrange first and second place out of these 10 finalists. Let's go to the next problem. In problem 2, we have that in an Epic Minigames round, there are 11 total players. If 5 will win at the end of the round, unranked, how many different arrangements of winners could there be? So let's write down the important numbers first. We have 11 people that are players, and out of those 11 players, only 5 will win. So I'm going to write 5 winners. So notice that 11 players is just our n value, because that's the total number of objects, or in this case people, that we have. And out of those 11 people, 5 of them are going to win. So there's 5 positions we're selecting into, or putting into. So that's our R value. Now the most important question is this a permutation problem or a combination problem? Well, notice that they said that there are 5 winners and they're unranked. In other words, there's no first, second, third, fourth, or fifth place. They're all just you either winner or you're not. Therefore, order does not matter. So I'm going to say order does not matter. And order does not matter means you use a combination. So let's write the appropriate expression for the combination. For a combination, you write 11 CR, and this is equal to, remember the formula for a combination is n over n minus r factorial times r factorial. So let's just plug in n and r. This will be 11 factorial on the top divided by 11 minus 5 factorial on the bottom, and then times 5 factorial. Now, we know that 11 factorial, or 11 minus 5 factorial, is just 6 factorial. And then now let's try and solve this. So first thing I'm going to do is rewrite 11 factorial as 11 times 10 times 9 times 8 times 7 times 6, and then notice that it'll go down from 6 as 6 times 5 times 4 times 3 times 2 times 1. Therefore, you have 6 factorial here, and you can just cancel this 6 factorial and that 6 factorial over there. So now let me just rewrite this. So now we have 11 times 10 times 9 times 8 times 7 divided by 5 factorial. And I can just rewrite that as 5 times 4 times 3 times 2 times 1. So now from here, you can just compute the top and the bottom number. If you do 11 times 10 times 9 times 8 times 7, you'll find out that that's 55,440. And if you do 5 factorial, 5 times 4 times 3 times 2 times 1, that's 120 if you do the math. And then if you divide those two numbers, you get 462. So there's 462 unique ways that 5 winners can be chosen from 11 players in this Epic Minigames round. Let's move on to the next problem. Problem 3 tells us that Builderman wants to play 5 games on Roblox. However, he only has time for 3. How many different combinations of games can he play? So let's write down the important numbers. There are 5 games on Roblox that Builderman is thinking about playing, but he can only play 3 of them. So let's think about which number is n and which is r, so we can set up either the permutation or the combination. Well, here he's choosing out of 5 games. So n is the number of objects you have that you're choosing from. That's 5. And that means R is therefore 3 because you're selecting 3 games out of those 5. So that's our R value. So now, question of the day, permutation or combination? Well, I kind of gave the answer away in the problem by saying how many combinations, but the reason it's a combination is because it doesn't matter the order of games that he plays. If he plays Jailbreak and then Natural Disaster Survival, that's the same as playing Natural Disaster Survival and then Jailbreak in this problem. So order does not matter, therefore we use a combination. So let's set up the combination. That will be 5c 3, and then remember that's n factorial, which is 5 factorial, divided by n minus r factorial. Well, 5 minus 3 is just 2, so that's 2 factorial, and then times r factorial, which is just 3 factorial. So let's solve this. I'm going to move down here. We have 5 factorial. I can write that as 5 times 4 times 3 times 2 times 1 is just 3 factorial. And then what that allows me to do is cancel out the 3 factorial in the denominator here. So what I'm left with is 5 times 4 divided by 2 factorial, which is just 2 times 1. Or that's just 2 only, because 2 times 1 is just 2. So let's just do the math, because this one is simple to do. 5 times 4 is 20. 20 divided by 2 is just 10. So all this means is that if Builderman can play 3 games only out of 5 he wants to choose from, there's 10 possible combinations for him to play. Let's go on to problem 4. This problem says, how many ways can we arrange the letters in Roblox? So I have Roblox written down here, and first thing I'm going to consider actually is it a permutation problem or a combination problem before considering what n and r are going to be. Well, let's think. If I write the letters like O, B, X, R, L, O, well, clearly that's a combination of letters that is different from that one. In other words, the position of the letters matters. So therefore, there is an order in these problems, or in these letters. So therefore, when order matters, you choose permutations, not combination. So therefore, this is a permutation type of problem. Now let's talk about how you actually calculate the answer. So I have P, and then what are my N and R values? Well, there are 6 different letters that we're choosing from. There are 6 objects. So that's just 6 here. And then how many positions are we placing them into? Well, if 6 letters go in, 6 letters must come out because we're just scrambling these. So actually, there's 6 positions as well. So this is 6 permute 6. Let's find out what that ends up being. That'll be 6 factorial divided by 6 minus 6 factorial. And 6 minus 6 is 0. So this is 0 factorial. What in the world is 0 factorial? Well, this is just one thing that you need to know for any problems you might encounter. 0 factorial is just 1. So in other words, this is 6 factorial divided by 1 because 0 factorial is just 1. So in other words, whenever you're permuting a number of objects into the same number of positions, the answer is just that number factorial. Now, we're almost done. Normally this would be the case, but there's one thing you need to watch out for. Notice how we have repeat letters. So notice if I had R, B, L, X, and then if I flip these 2 positions, I'd also have O, R, B, L, X. Well, wait a minute. I just flipped these letters, so that should be a different combination, but they look identical. These are the same thing because these are the same letter. So there's repeats in our problem. There's repeat letters. How do you account for that? The solution is very simple. What you do is you divide by the number of repeats, or you take each repeated unit, O, and there's 2 repeats. So you do 2 factorial. If there were 3 O's in Roblox, for example, I would do 3 factorial in the denominator instead, just as another example. But here, we only have 2 O's. So you take your repeated unit, and then however many times it appears, do that much factorial as another factor to divide by. So this is our actual answer. And then now let's compute this. I'm just going to move down here. We have 6 factorial divided by 2 factorial. Well, 6 factorial is just equal to 6 times 5 times 4 times 3 times 2 factorial, because 2 times 1 is 2 factorial, so that cancels out. And all we're left with is 6 times 5 times 4 times 3 for our answer. So this is just simply computing it. If you put that into a calculator or do it by hand, that's 360. So in other words, the number of ways that you can arrange the letters in Roblox is 360 ways. Let's go on to another similar problem. A similar problem says, how many ways can you arrange the letters in KreekCraft? So this is a very similar setup to the previous problem because we're just mixing letters up to get new combinations. So first thing I'm going to do is I'm going to count how many letters we have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. And then this is a permutation problem because the order matters, just like in the last problem. And we're putting 10 letters, which is our n, into 10 different positions because we're using all those letters again. So our r value is also 10. And remember, whenever we have the same number that's being permuted for n and r, this is just equal to that number factorial. So 10 factorial. However, that's not our answer just yet, because now we need to account for repeats in KreekCraft. So let's see what we have. Notice how there's two K's in KreekCraft. There's this K and then there's that K. There's also two E's right over here. And notice how there's two R's as well. So there's three different repeats. There's a 2 K's, 2 E's, and 2 R's. So remember, the way you count for that is for each repeated unit, you divide by the number of times it appears, factorial. So 2 K's means 2 factorial, 2 E's means 2 factorial, 2 R's means 2 factorial. And then 2 factorial is just 2 times 1, which is 2. So at the bottom, we just have 2 times 2 times 2. So 2 times 2 times 2, and 2 times 2 times 2 is just 8. And then for 10 factorial, that would just be 10 times 9 times 8 times 7 times 6. I'm just going to draw a dot dot dot, all until you have times 2 and then times 1. Now granted, this is a lot to compute at once, and I wouldn't recommend doing this by hand. So I would just take out a calculator and compute what 10 factorial is. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. If you do that, that's just 362,800, and I think I said the wrong number. It's actually 3,628,800 divided by 8. And then if you do that math on a calculator, that's 453,600. So this means that there's this many ways to rearrange the letters in KreekCraft's name to get unique combinations. This problem now says, on Roblox, you can wear up to 3 hats on your avatar. If I have 6 hats, how many different ways can I wear hats if I wear at least 1 hat? So first thing I'm going to do is write a couple keywords for this problem. Notice how this problem says you can wear up to 3 hats. And it also tells us that you're going to wear at least 1. So what does this mean? Whenever you see the words up to and at least in a combinatorics problem, you need to think about the possible combinations. What I mean by that is that in this problem, we can either wear 1 hat, or we can wear 2 hats, or we can wear 3 hats. And to solve this problem, all you need to do is just add up these possibilities. So add up the possibilities for wearing 1 hat, add up the possibilities for wearing 2 hats, and then 3 hats. And if we add all of these up, we can get the total number of combinations, or the total number of ways you can wear hats if you need to wear at least 1 hat, and you can wear up to 3 hats on Roblox. So let's do the math now. I'll start with 1 hat. To do this, well, this one's pretty simple. If you have 1 hat, and if you're wearing 1 hat and you have 6 different options to choose from, that's only 6 possible choices. I don't even need to do combinatorics for that one. For the next one, if we have 2 hats, well, let's think about how to do the combinatorics for this one. If we have 6 hats to choose from, and then there will be 2 hats we're taking out of those 6, our N and R are 6 and 2 respectively, Do we use a combination or a permutation here? Well, here's the thing. Whenever you wear hats on Roblox, it doesn't matter what order you wear them in, because at the end of the day, if you chose those two hats, you'll still be wearing both of them, and it doesn't matter how you order them, it won't look different. So order doesn't matter. So this is a combinatorics or a combinations problem. So therefore, I'm going to write 6c2, and then that's just equal to 6 factorial divided by 6 minus 2 is 4 factorial, and then you have 2 factorial. And then to simplify this a bit more, we have 6 times 5 times 4 factorial on the top, because that's how you can rewrite it, divided by 4 factorial times 2 factorial. So that means we just have 6 times 5 on the top, and then 2 factorial on the bottom. And 2 factorial is 2 times 1, which is just 2. So at the end of the day, we just have 6 times 5, which is 30 over 2. And 30 over 2 is just 15. So all this says is that if we're choosing 2 hats out of 6 options, there's 15 ways you can choose that. So now I've done the 1 hat and the 2 hat cases. Let's work on the 3 hats now. To do this one, this is just 6, choose 3, we do combinations here. And that's equal to 6 factorial divided by 3 minus, or 6 minus 3 is 3 factorial, then times r factorial, which is 3 factorial again. So to simplify this, I can write this as 6 times 5 times 4 times 3 factorial divided by 3 factorial times 3 factorial. I can cancel one of these 3 factorials from the top and the bottom. So that leaves me with 6 times 5 times 4 divided by 3 factorial. And 3 factorial is just 3 times 2 times 1. And that's just 6. And notice how we have a 6 in the numerator and the denominator now. Those cancel. So all we have left is just 5 times 4. And that's just 20. So all this says is that if you're choosing 3 hats out of 6 options to wear, there's 20 different ways you can do that if the order doesn't matter. So I'm going to fill in a 20 here. And now all we need to do is just add up these numbers. So there's 6 ways to choose 1 hat, there's 15 ways to choose 2 hats, and there's 20 ways to choose 3 hats out of 6 total hats. If you add all those up, you get 20 plus 15 plus 6 is just 41. So if we have 6 hats, and I can choose either 3 hats, 2 hats, or 1 hat, there's 41 ways you can wear these hats. Let's move on to the next problem. Let's try this similar problem out now. This one says, I'm building a team to fight monsters in Dungeon Quest. The team will have 5 players aside from myself. There are 7 noobs and 6 pros to choose from. If I need to take at least 3 pros on my team, how many different teams can I make? So once again, notice how we have the word at least, and it says at least 3 pros. So this means we'll need to consider multiple possibilities. So I was thinking what those possibilities are so I can find each of the combinations for those possibilities and add them up. So we have at least 3 pros on our team, and there's 5 people aside from myself that's going to be on this team. Let's think of what options we have. We can have 3 pros, and then if you have 3 pros, that means we must have 2 noobs left to fill the 5 on the team. Okay. Or we could have 4 pros, because that's more than 3. But if we have 4 pros, that means there's only going to be 1 noob left. Because 4 plus 1 is 5, and you can't have more than 5 people aside from myself, as I said in the problem. Or our final option is 5 pros, because we can have up to 5 people on a team, and there's enough pros for that. There were 6 pros to begin with. And if we take 5 pros, that means we're going to have 0 noobs on our team. So these are our 3 options, and we just need to calculate the possibility of each one. So let's do that. I'll start with the 3 pros and the 2 noobs. So I'll go over here and do this. So I'm going to write down 3 pros and 2 noobs. I'll just write that as P and N for short. So for the 3 pros, we have 6 pros to choose from, and there's 3 different ones we're picking. Is this permutation or combination? Well, because we're just selecting team members, they're not ranked or they're in any order. If I choose 3 people and then I scramble those 3 people, they're still the same 3 people, so order doesn't matter. So that means we do combinations, because order doesn't matter in combinations. And then what about the noobs? If I'm choosing 2 noobs out of 5 noobs to begin with, or sorry, not 5, it was 7 noobs to begin with, that's also a combination problem because it doesn't matter the order of those noobs. So 7C2. And then what you have to do is once you calculate the pro combinations and noob combinations, you have to multiply these quantities. And that's because for every combo we have in here, we could pair that to another combo in here with the noobs. So you have to multiply those numbers to get the total number of combinations for 3 pros and 2 noobs. So let's just do the math for this really quickly. So 6C3 is 6 factorial divided by 3 factorial, 3 factorial. I'm going through this quickly because we encountered this in the previous problem. And then remember, that's just 6 times 5 times 4 divided by 3 factorial because the other 3 factorial canceled out. If you need to review this, please review the last problem. And then when you did this, you got this was just 20. And then let's find out what 7C2 is. That will be 7 factorial divided by 7 minus 2 is just 5 factorial. And then times 2 factorial because you need r factorial. 7 factorial is just 7 times 6 times 5 factorial. That cancels, and you're left with 7 times 6 divided by 2. 7 times 6 is just 42. 42 divided by 2 is just 21. So 20 times 21 is our answer for how many ways we can choose 3 pros and 2 noobs. If you do that, I believe that is 420. So now I'm just going to save that number at the top here. I'm going to say, let's move here. I'll say this is equal to 420. Then now let's work on 4 pros and 1 noob. So we have 4 pros and 1 noob. It's just pretty simple now. Just replace the R number because we still have 6 pros to choose from and 7 noobs to choose from. But this time we're picking 4 of those pros and 1 of those noobs. So we just need to do the math again now. So if we do 6 choose 4, we have 6 factorial divided by 6 minus 4 is 2 factorial times 4 factorial. 6 factorial is just 6 times 5 times 4 factorial. Those 4 factorials cancel out. And that just leaves me with 6 times 5 divided by 2 factorial. 2 factorial is just 2. And 6 times 5 is just 30. 30 divided by 2 is just 15. So 6C4 is just 15. And we need to multiply by 7, choose 1. Well, think about it. If you're choosing 1 player from 7 different players, there's only 7 choices, right? So just 7. If you do that math, that's 105 total options. So there's 105 ways you can choose 4 pros and 1 noob out of these people. So let's save that number. So this is equal to 105. And finally, let's work on 5 pros and 0 noobs. So I'm just going to rewrite 5 pros and 1 noob here, or no noobs. So notice, if we're not picking any noobs, we don't even need to consider them. So we're just worried about the pros now. So if we're choosing 5 pros out of 6 total pros, we just write the expression here. That's 6 factorial divided by 5, or 6 minus 1 factorial is just 1 factorial times 5 factorial because we need to write r factorial again. And if you do that, that's just 6 times 5 factorial on the top divided by 5 factorial on the bottom. Well, that cancels very nicely, and all we're left with is 6. So all this says is that if you're choosing 5 pros out of 6 total pros, there's 6 ways you can do that. So I'm going to erase all this here and put a 6 up there. Oops. And now, to find the total number of ways we can make a team, we just add all the possible combos up. So we have to add up the 3 pro and 2 noob combos with the 4 pro and 1 noob combos, and then the 5 pros and no noob combos. So let's just add all these numbers up. If you add up all these numbers, you'll find that it is 531. So there's 531 ways to make my dungeon my Dungeon Quest team if I specify it like in the problem above. Let's move on to another one. This new problem says, I am building an obstacle course on Roblox. I have 5 obstacles to place in any order I want, but I know that there's 2 obstacles I want to be next to each other. How many ways can I arrange my 5 obstacles? So let's draw this out and think about how to deal with this problem. So if I just have 5 obstacles. Let's just call them A, B, C, D, E for short. I can order them in any way possible, but I want you to notice something. Notice how I said that 2 of these obstacles are going to be next to each other, no matter what. So let's say these 2 are the obstacles I want next to each other. Let's think about a few different combinations I could build like this. Maybe I have D, E, A, C, B. Notice how D and E are next to each other. Or maybe I can have C, B, E, D, and then A. And E and D are next to each other because I said these are the 2 obstacles I want to be linked to each other. So the way you can think about this is that notice how there's actually only 4 objects in this group, because this E and D here, or this D and E, acts as one object because it moves together. So notice how there's only 1, 2, 3, 4. There's only 4 objects we're dealing with. Even though I said there's 5 obstacles, you can think of this problem as having 4 total objects because D and E are always moving together. You can't separate them because the problem said you need to have 2 obstacles next to each other. So all we need to do is we're putting 4 obstacles into 4 positions if you count E and D as 1 total obstacle. And then this is a permutation because the order matters. And then remember, when you have the same number on both sides of the permutation operation, that's just 4 factorial, or that number factorial. So now 4 factorial is just 4 times 3 times 2 times 1. If you do that math, that's 24. So it seems like we might be done now. The answer seems like it's 24, but we're actually missing one thing. Notice how in these combinations, I have E and D and E next to each other, but can't I flip them? Because it said they have to be next to each other, but it didn't specify the order they go in. So, for example, here, I could have D and then E if I change this. If I change this one, I could have E and then D. And at the top, I could have E and then D as well. In other words, for the 24 combinations we created, you can also flip those 2 obstacles around to create a new combination. So the adjustment is just multiply by 2. So 24 combinations for those 4 objects times 2, because we can flip the positions of those 2 objects, D and E. So our final answer is actually 48. So there's 48 ways to build my obby if I have 5 obstacles and 2 of them must be together, but the order of those 2 that are together is not specified, hence we multiply by 2 at the end. Let's move on to the next problem. In this problem, we have that 6 players are sitting around a campfire in the horror game Camping. How many ways can they sit? So what you might think is that we have 6 people being placed into 6 positions, and order does matter because you can sit in different orders. So I might think the answer is just 6p6. But believe it or not, this is not the case. And the reason is because this is a circle, or this is a circular problem, or you're placing objects in a circle, and things get weird when you place things in circles. Let's talk about why. To show why you can't just do 6p6, let me just draw a small circle. Let's say we have, 3 players sitting out in a circle. Let me just call them A, B, and C, and they're sitting in a circle. If this is one conformation, what if I just rotate everybody by 1 place? Then they become A up here, B down here, and C down there. But then notice, this is just the same order but rotated. So if you try to do 6p6 in this problem, what happens is that you count all these rotations that are actually the exact same thing, because this order on the left is not fundamentally different from the order on the right, because a simple rotation would prove that they're the same. Compare this to if I had B here and then A over there. Now if you stare at these for long enough, I think you can realize that these are fundamentally different things, because going clockwise on this left one, you go from A to B to C clockwise. If we go clockwise on this one, you go from A to C to B, which is not the same order. So basically, whenever you have problems that place things in circles, you have to apply some sort of correction. So what in the world is that correction? All you do is you take your n objects, and then you subtract 1 from it. And I promise you this will do the trick every time. And then that's your new n value. So here we had 6. So you subtract 1 to get 5. So actually in this problem, you want to pretend there's 5 objects. So 5 permutation 5 is just equal to 5 factorial. And that's equal to 120. So that's our answer for this problem. There's 120 ways to seat 6 people around a campfire if they sit in a circle. Now I'm going to show you a slightly harder extension of this problem, so let's get to that. I've added an extension to the previous problem. It says that if 2 players must sit next to each other, how many ways can they sit in the circle now? What I'm going to do is I'm just going to draw some players. So let's say I have player A, B, C, D, E, and F. And let's say 2 of these players have to sit next to each other. So let's say A and B, these players must sit next to each other every single time. Well, I want you to notice something now. Notice how, just like in the obby problem, we now have less total objects. So now A and B can act as 1 object in total. So I have 1, 2, 3, 4, 5 things. So instead of 6 players and 6 objects, you can think of this as effectively being 5 players since A and B are sitting next to each other. And then remember, for a circle problem, instead of having n objects, you do n minus 1 to apply a correction to it. So now our new n value is 5, so I do 5 minus 1. So our new n value is just 4. So now you can think of this as arranging 4 objects in an order. So that you do 4, permutation 4, and then that's just 4 factorial, which is just 24. But remember, we weren't done in the obby problem when we got to this answer. Remember that for every arrangement that has A and B in it for these players, we can swap their positions. So maybe you have B here and A over there. So A and B can swap places in every single of these 24 conformations. So what's the correction? You just multiply by 2, since you can have either A, B, or then B, A in different orders. So when you do that, the answer is 48. So that's how you solve this extension. If you enjoyed this video, please consider leaving a like and subscribing. Thank you for watching.